Hey everybody, this is Mr. Walker, and these are your corrections for Test 2B, linear equations. What you need to do for this ed puzzle is answer the questions that follow the ones that I go over. These questions are the ones that were the most missed on the test. Once you guys are done, please make sure that you email me to let me know if you need me to reset your score. In order to get the test corrections and bump your test to a 70%, you're going to have to get a 100 on this ed puzzle. So let's go ahead and get started with the most missed question, this one right here. The graph below represents the cost, C, in dollars, of green squash at a grocery store based on the number of pounds that you buy. So just to kind of like highlight what they're talking about here, they're saying that the cost depends on how many pounds of squash that you buy, which makes sense. If you look at this, the more pounds that you buy, the higher the cost is going to be. So the more you're going to spend. All right, so I just wanted to kind of interpret what they're showing us. I always look to see what it is that they're giving me first and kind of understand it the best to begin before I even look at the question. Okay, so I haven't even answered or started looking at answering the question yet. All right, so let's move down here where it says the cost per pound of green squash at a local farmer's market is half the cost of green squash at the grocery store. Select the equation that best represents the green squash at a local farmer's market. So let's kind of highlight some stuff here. So let's see. It says that the cost per pound, so at a farmer's market, is half. Okay, so it's saying it's half the price of the grocery store. Okay, select the equation that best represents the cost at the farmer's market. All right, so we're trying to figure out an equation that would help us determine how much money we would spend at the farmer's market. First thing that we know is that it's half the price of the grocery store. So let's kind of look up here at the grocery store's cost. It looks like if I'm using this chart, this would be 2 pounds costing, I don't know, maybe 250, a little bit higher. I can't quite tell. This spot right here is 8 pounds costing almost 17.50. I can't quite tell if it's there, but this one actually I like because it's right on the line. So this says that 10 pounds costs $15. All right, so now I'm gonna kind of go back on that. I should have there, $15. All right, so 10 pounds, $15. So what that tells me is that 1 pound, if I wanted to figure out what one of those pounds was, I would divide 15 by 10. All right, it would give me how much it is per pound. So 15 divided by 10 is 1.5. And since we're talking about money, it's good to put another decimal point because remember, whenever you see money written out at the store, it has 2 digits after the decimal place. That's 50 cents. 0.5 is the same as 50 cents. All right, so I know that at the store it costs $1.50, and at the farmer's market it costs half as much per pound. So if it costs $1.50 for 1 pound at the grocery store, half of that, half of this, would be 75 cents. Okay, so looking at my options, the cost is equal to 75 cents times the number of pounds. So let's see. This one shows it's $6 a pound at the farmer's market, $3 a pound at the farmer's market, $1.50, which we know is the price at the grocery store, and this one would be the correct answer. I have a feeling that most people missed this problem because they were thinking, what's the equation for this line? The equation for the line at the grocery store would be C equals 1.50 P. That's for the grocery store, but we have the question, how much would it be at the farmer's market? So letter D is the correct answer for that one. Remember, to find the unit rate or the price per pound find a spot where you can actually figure out what the number of pounds is and the number of cost, the number of dollars it would spend, and divide it. So 15 divided by 10 gave me this. 1 pound is $1.50. And then to go to how much it costs at the farmer's market, I divided by 2 because they told me that it should be half of the price of the grocery store. All right. Next question for you guys is I want you to write down the equation that represents this line in slope-intercept form. So remember, in slope-intercept form, you need y equals the slope x plus b. The y and the x won't change. The slope depends on what your graph looks like, and the b is your y-intercept. So where does it cross the y-axis at? All right, let's take a look at our second most missed question here. The table shows the proportional relationship between time and hours that Sarah babysits and the amount in dollars that she earns babysitting. So let's just try to figure out what they're actually showing here. So how much time she spends babysitting and how many dollars she makes is using A. So this first row right here, I can see, okay, she makes $8 in 2 hours, $12 in 3 hours, $16 in 4 hours, and 20 in 5. Okay? All right, so let's try and figure out how much money Sarah earns per hour. So in this case, we're looking for her slope, the slope. The slope represents the unit rate or the rate of change. Now to do that, you could choose any 2 rows here and find the difference in the amount of money that she makes and the amount of time that it took her to make that much money. So let's take a look. So to go from 12 to 16, she's going up 4, right? So that's positive 4. And then it took her from 3 to 4 hours. So that's only a change in 1 hour. So it took her an hour to make $4. Now in slope form, you would probably write it something like this: 4 over 1, which is the same thing as 4. So $4 per hour is what she makes. That's what Sarah makes. All right, now the equation 5H shows the relationship between the amount of in dollars Abby earns while babysitting. Okay, so this equation right here is for a separate person. It looks like they're talking about Abby here. They're talking about dollars and hours. And if I look at if I wanted to create like a similar table for Abby to what Sarah had, you could see, okay, in 0 hours, 0 times 5, so 5 times 0 would be 0, so she makes no money in 0 hours. If you put a 1 where the H is, 5 times 1 is 5, and then 2 would be 10. So you can kind of see that there's a pattern going on here. She's making $5 per hour. The amount that it changes from here to here is 5. And in order to do that, it was only 1 hour. So $5 per hour. So looking up here at our options, Sarah earns $1 more than Abby. We know that's not true. She's making less. Sarah earns $4 more. No, she's making less. Abby earns $1 more an hour. Yeah, if you compare 4 to 5, you could see Abby's making more money by $1. All right. Very similar question. What I want you to do on this question is to select all the true statements. There are 2, so you need to pick 2 of these that are correct. Okay, 2 of them that are correct. Okay, I give you a table and an equation just like from before, and you need to compare the y-intercepts and slopes. All right, third most missed question here. During a snowstorm, snow falls at a constant rate and is recorded by a meteorologist. The data is plotted on the graph below. So let's kind of take a look. All right, so this is a snowstorm. This is a meteorologist, somebody who studies weather. Let's kind of clarify that. Then they plot the data for snow falling, and it's at a constant rate. So it's going to go up in a straight line. This X value represents the number of hours. So after 1 hour, 2 hour, 3 hour, 4 hour, 5 hours, and then it looks like they record how many inches are on the ground. All right, so let's take a look and see which equation models the relationship between the number of hours, X, in the snowstorm and the number of inches of snow, Y, on the ground. So remember, all of your equations will be written as Y equals mx plus b. You could start off with either one of these, the m or the b. B is the y-intercept, m is the slope. B is where does it cross the y-axis. So this is your y-axis right here. So you can see that it crosses right here at the 3. So your y-intercept is 3. The slope is the rise over run. So how much does it change in y and change over x? So let's see, it's going from 3 to 6. So that's a difference of 3. And then it's really only going over 1. It looks like it's going over more, but this distance right here on the x represents 1 hour change. So it keeps going up like that. Up 3 spots over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. One line on the y value represents 3, and it takes 2 lines on the x value to make 1. So the slope is 3 over 1, which is the same thing as just 3. So I could write my equation now from that. Y equals 3 is the slope, x plus 3, the y-intercept. Looking at my options, you want to choose option A. A line that looks like letter B would be starting at the same spot because they have the same y-intercept, but it's only going to go up 1, which would be at 4, like somewhere right there, over 3, which would be like right there. Remember, it has to go over 3. Up 1 over 3. And these other two have a y-intercept of 18, which would be a line starting up here on the y-axis. All right, guys, here's your choices. What I want you guys to do is match the equation with the line and then move on to the next question. Very similar question. All right, and your last question before you guys do your own question. The last question that I'll go over is this one. This is the fourth most missed question. Let W represent the number of cups of water necessary for C cups of concentrate. So they're comparing cups of water and cups of concentrate. The relationship between W and C for peach raspberry juice and lemonade is shown in the graph. So the juice for the peach raspberry is here. The equation for the lemonade is here. This looks pretty similar to our second question. All right, so what we can do, if you want to, we could write an equation for the peach raspberry based on the graph. Remember, all of your lines should be y equals mx plus b. In this case, they're using the letters W for the Y and C for the cups. And we need to figure out what is the slope and what's the y-intercept for the peach raspberry. So slope's pretty easy to, our y-intercept's easy from here. You could see that it's 0, crosses the y-axis right there. So we don't need to put anything for here. Plus 0 is, you don't need to add that. You could, but you don't really need to. It's not necessary. The slope, so let's kind of take a look and see. I could see that it goes from 0 all the way up to 22, so that's up 22. and then it goes over to this 8. So 22 over 8. Sometimes it's nice to simplify your equations or your slopes. So you can write them as fractions, mixed numbers, decimals. So if you change that 22 over an 8 to a decimal, it's the same as 2.75. So these two equations are just the same. It's just one is written with an improper fraction, the other is written with the decimal. Okay, so that's for the peach raspberry, and then you have your lemonade right here. Let's take a look. It says determine whether each statement is true. Select true or false. So let's see. The peach raspberry juice requires 2.75 cups of water per cup of concentrate. So if I use 1 cup of concentrate right here, if I replace that with a 1 in the peach raspberry juice, I would need 2.75. So what you could do is you can multiply 2.75 times 1 and you get 2.75. So that's true. For every 1 cup of water concentrate, you need 2.75 cups of water. Or yeah, that's right. Every 1 cup of concentrate needs 2.75 cups of water. Moving on, the peach raspberry juice requires less water per cup of concentrate than the lemonade. Well, let's see. The peach raspberry, which is this equation right here, needs 2.75 cups of water for every cup of concentrate, and the lemonade, which is right here, the slope is the rate of change, or your unit rate, needs 6.5. So yeah, the raspberry juice, peach raspberry, does need less water. And then let's look at the last one. The peach raspberry juice requires exactly half as much water per cup of concentrate. So is 2.75 cups half of 6.5? So the only way to find that out is to divide your 6.5 by 2 and see if it's exactly half. So exactly half, 6.5 divided by 2 is equal to 3.25. So exactly half would be this. So it's not exact. Like these two numbers are not the same. So it's not exactly half. So this one is a false statement. Okay, so the thing is with this one, you have to determine what the slope is. Okay, the slope is the rise over the run. So count up, count over, make it a fraction like I did over here. And then make it into a decimal number similar to the lemonade. That way it's easy to compare the two. And then from there, you could answer your questions. Okay? All right, last question. So I want you to select all of the true statements. Select all that are true. I believe there are 2 correct there. So make sure that you guys select all that are true. Remember, email me once you're done if you need me to reset any of your scores. Have a good rest of your day, and I'll be looking forward to those emails.